Hello Year 12, welcome to the fourth video here for AM5, nonlinear relationships. We've looked at quadratics so far and applications of quadratics, maximum and minimum problems. We looked at cubics in the last video, and now we want to look at hyperbolae, right, the hyperbolic function. Whereas a quadratic takes the form y equals x squared, cubic y equals x to the power of 3, a hyperbola is y equals 1 over x. Right, or xy equals 1. Right, generally, we recognize these hyperbolae because x is in the denominator. Now, there is something a bit curious about this that's quite different to other graphs we've looked at so far, because there is a restriction now on what x could be. If I draw up a table of values and I try to find out what happens when x equals 0, I will have a problem, because I can't divide by 0. So this graph has sort of a gap in it, right, at x equals 0. Now, what the shape actually is, it looks like this. Now, when x is very close to 0, but positive, 1 over that number is quite a big number. So it looks like this. I get this sort of thing going on. And if I have negatives, I get this going on. Right, so I get this weird leap from x, something like x equals negative 0.001. Right, 1 over that would be negative 1,000. If I go forward just a tiny bit to positive 0.001, then all of a sudden y leaps all the way up to 1,000. Right, it's gone from negative 1,000 to 1,000, right, in a tiny change of x. This is a hyperbola. Right, and that's our basic form here. Right, these lines that it approaches, and the same goes here for the x-axis, both the x and y-axes, the graph gets really close to those but never reaches it, never turns away from it, continues to approach both of those axes in certain directions. We call these asymptotes. Right. Often we'll label them on a graph with a dotted line, but when they're the axes, it's a bit hard. Asymptotes are what they're called. Here's this word here, asymptotes. Right, it gets closer and closer, never quite reaches. Now, negative 1 over x, remember that negative flips it top and bottom. Right, so I get this x-axis and my y-axis. There we go. That's the graph of y equals negative 1 over x. First and third quadrants, right? 1, 2, 3, 4. That's the order we count them. 1, 2, 3, 4. So the graph of this one is first and third. This is in the second and fourth quadrants. Now, what happens when I do this? Typically, we have said that number makes it steeper. That's not really the case here. What this really does is it actually keeps it further away from the axes. So 4 over x, compared to if I put this in as 1 over x, the dotted line here, if that should be y equals 1 over x, then 4 over x will sit sort of outside of it. Right, compared to the 1 over x, which is that dotted line. So you wouldn't normally draw that. I'm just to sort of recognize the difference there. It sits a bit further away from the asymptotes, close to the intersection of those asymptotes. Of course, it still gets very close to the asymptotes as you go right down here or right up here or out to the sides here. Now, 1 over 4x does the reverse. Okay, this time, I'll be extra close to the axis this time. Got that right? X and the y-axis there. Rightio. So this is like 4 times. In fact, one way that you can think of this is if I draw a rectangle in here, the area of that rectangle wherever it is, whether it's right up high here or right down low here or right in the corner, is going to have the same area, has an area of 4. Okay, because the length times the breadth, right, will be x times y. X times y equals 4. X times y equals 1/4. So my rectangle here is much smaller. Change widths, if you like. A larger number will be wider, which is the opposite to what we've seen with the others. And a fraction will make the graph narrower. Right, certainly closer to the asymptotes early on. Curious. Rightio, they are hyperbolae. Again, the main thing that I need you to do with these is to recognize them, is to match an equation with the graph. Okay, to see this here and go, you know what? I see I have a 1 over x, that makes it a hyperbola, and there's a negative there, so it's second and fourth quadrants. Okay. Rightio, thanks very much, guys. See you in class.